Thank you all for standing by, and welcome to today's webinar, Provisioning and Managing Kubernetes on AWS with HashiCorp Terraform. Please feel free to type in your questions during the webinar. This webinar is being recorded, and the recordings will be made available after post-processing, usually within about 2 days. Our speakers today are Adam Cavaliere, Senior Solution Engineer from HashiCorp, Chris Hein, Container Partner Solutions Architect from AWS, and Ben Somogyi, Principal Systems Architect from Pearson. And now, let's get started. Adam?
All right, thank you, Peter. So all right, we're going to kick this off by speaking about how organizations are embracing a multi-cloud set of technologies with Terraform. And, you know, as organizations are looking to embrace the cloud and make it their unbounded data center, they're looking for ways to do so in a safe and efficient manner. And so when we really talk about embracing the cloud and what that means, it's really about figuring out from a cultural and technology standpoint how you're going to embrace these solutions. And so, you know, when we look at the reality of taking on new solutions, it really comes down to looking at all of the different requirements which may dictate operating even in different cloud environments. And I think as we look at the the business landscape, they're going to dictate that you need to move a lot more quickly than it typically takes to onboard new solutions. We found that it typically takes about 6 to 12 months when you boil down all of the different integrations you have to look at from a their model of the way that you want to integrate with their solutions to understanding the nuances of those pieces. And so when we look at how can we really effectively allow the business to take on these new capabilities without slowing down, we look at solutions like Terraform, where we already realize that you have a common workflow. And the best choice here is to utilize a technology that allows you to consume whatever data center or provider you choose, essentially to be boundless. And this then allows you to focus on things like bringing that new business unit, which is focused on data sovereignty laws. So how do we bring them on as quickly as possible without slowing down what ultimately could be a big impact to the business, to utilizing even existing resources from investments we've already made in the equipment in your own data center, to focusing onboarding the latest and greatest technologies that are being made available all the time. Obviously, the point of this webinar is to talk about EKS, and it's a great example. And so when we look at what the status quo really yields, it really comes down to a very complex multi-cloud model, where we may already have a private data center that has admins that have already taken care of that part. But as we start to on-ramp new technology, let's say we start to on-ramp AWS, we have cloud migration teams, and when they look at the tool sets they need to learn, it takes a while to on-ramp those technologies. And as more teams look to on-ramp, along with that, even other technologies that they look to utilize, it becomes a lot of effort for the organization itself, and they realize quickly that they're all essentially trying to do somewhat of the same thing, and so rather than taking the time for people to ramp up on these different areas, it makes a lot more sense to utilize a tool like Terraform that provides this layer of abstraction. And it also provides a very safe and predictable workflow while still offering the native capabilities of each of the solutions you're looking to deploy. And that's really key, is that it's not trying to boil down to the least common denominator, but that you can get to the nitty-gritty capabilities of each one of those different resources. And so from a HashiCorp perspective, there's always a better way. And we don't want you to rely on the standard processes that have always been there. If we look at infrastructure providers today, there are ways to address them with code. And so instead of trying to do things manually and provision manually, let's take the best practices approach from software development and use those to codify the way we approach infrastructure. This eliminates any kind of tribal knowledge where somebody believes that they're following a process, they go through and do it, and somebody else tries to follow that same process and does it just slightly differently. Instead, having an infrastructure as code approach allows us to all understand what's going to change and ultimately understand what's going to happen to the infrastructure over time as well. And the next step is to really focus on provisioning workflows, which allow you to plan your changes and execute your changes separately, all while doing this obviously safely and efficiently. And this is a big part of what Terraform brings to the table because of the way that it's been built to do both plans and applies. And the final part, and most exciting, is really that much like all the HashiCorp tool sets, it's built to be extensible. We have over 120 providers available today with over 1,200 resources. And the beauty of Terraform is that the architecture allows for new and custom providers to be utilized at any time. So whether that's a new vendor designing their own provider or you crafting a custom provider for your particular use case, the possibility to utilize Terraform in your workflow is really endless. And so when we look at this multi-cloud model with HashiCorp Terraform, it really goes from months to just a few weeks of on-ramp time to bring on new technologies, because it becomes a very simplified way of approaching these different technologies. And so when we just look at Terraform from an open source perspective and enterprise perspective, the first thing that really comes to mind is that it's become incredibly pervasive over the years. We've seen that annually Terraform has been downloaded over 1 million times, and we have over 1,200 community members all contributing to Terraform. And so from an enterprise perspective, we have some of the top banks in the world utilizing Terraform to manage their infrastructure. And along with that, we have approximately 100 customers of the Fortune 500 utilizing enterprise HashiCorp tools. And this includes Terraform, Vault, Consul, Nomad. And so it really, you can see where the growth is happening with the HashiCorp tool set. And it's because of the way that we approach the infrastructure in general. And so, finally on the provider front, we've really seen this growth occur at a high rate. And I updated this slide recently because it actually, at the beginning of 2018, we're at about 70 providers. And at this point, we're actually at about 125 plus. So this is almost a doubling of where we were at the beginning of the year. And this, because of the community and really close partnership with providers like AWS, we've been able to multiple times have support for resources day one of a new solution being released. A great example of this is EKS. And so when we look at customers taking on Terraform and really going through this journey of utilizing it, we find that as you start out as an individual, it's very easy to use Terraform. But as you start to take on using this in the enterprise, there's going to be some organizational challenges. And so this is where Terraform Enterprise has really come to help greatly. And so, as we look at some of the challenges, we have solutions for them. And it comes down to things like collaboration. How do I take what I've done and collaborate together with my team on it so that we're all working off of this same set of code, and we all understand what's going on in the enterprise at the same time. And then along with that, how do I enable others in the organization to utilize and build off of what I've done from even a self-service perspective? So rather than recreating the wheel each time, let's utilize pieces that have already been built. And then finally, with policies and governance, it really is all around how can I allow us to move faster while still taking into account the policies and governance, which are really important to the organization. And so this is really about automation and the enforcement of policies. So rather than creating high-level rules and expecting people to follow them, let's embed them directly into the workflow and make it much easier for people to really take this on. And so moving into really the heart of the presentation today, we can see that from a Terraform perspective, we're able to, day one, release support for this. And it really is because of just how easy it is to onboard new solutions with Terraform. And I want to hand this over to Chris so he can, get started talking about how EKS can be embedded into your Terraform workflow.
Hi, everybody. Can you all see my screen? I think you can see my speaker notes. Great. Thanks, Adam. Hi, everyone. I'm Chris Hein. I'm a partner solutions architect at AWS, and I specialize in all things containers, and specifically working in the Kubernetes landscape around EKS and where we can go with our partners. So this morning, as Adam said, we're going to be talking about using Terraform and Amazon EKS to basically bring up clusters for you with using only Terraform. So before we get started, let's get everybody up to speed. For those of you who don't know what Kubernetes is an open source container management platform. It's been generally available for, as of this month, 3 years, and it was originally released in June of 2014. It's absolutely taken the world by storm in the last 12 months. The growth has been absolutely extremely rapid, especially against AWS customers. So when you actually strip away the hype behind it, at its core, it's built to help you run containers at scale and comes equipped with features and functions to build proper distributed applications using the 12-factor app pattern. So realistically, what we're getting at is, or what we learned was, where you run Kubernetes matters. The quality of the underlying cloud provider, the speed, the stability, and the integrations with the platform all impact the quality of the applications you build and how much work you have to do yourself, and ultimately, how happy your customers are and how quickly new features are introduced. So when we keep diving deeper into this, all this is just building blocks and microservice tooling to help you build cloud native applications. And our customers believe that there's a massive advantage in running Kubernetes on AWS. According to the last CNCF survey, over 50% of Kubernetes workloads were run on AWS today. And this has really organically grown, fueled by the strong community of developers that are behind the scenes, customers and partners that have really taken the Kubernetes landscape by storm. So let's take a quick look at what a typical Kubernetes on AWS deployment looks like. A typical Kubernetes cluster will look something like this, having multiple auto-scaling groups, managing the control plane, the etcd cluster, and the worker nodes. And as customers started running Kubernetes on AWS, they started to ask us to manage it. So we built Elastic Container Service for Kubernetes, or EKS as we call it. We know how important a Kubernetes service is to our customers, and so we really took the time to build it out exactly as we would want it. So to remove the complexity of standing up your own Kubernetes control plane, you connect into a managed Kubernetes endpoint in the AWS cloud. This endpoint abstracts the complexity of the Kubernetes control plane, and your worker nodes can check into the cluster, and you can interact with this Kubernetes cluster through your typical tooling that you already know and love, like kubectl. So let's talk about what it actually takes to bring up an EKS cluster. Since we're going into and talking about Terraform, this is the most important part for us. So first thing you actually have to do is create a service role. And behind the scenes, what this service role is doing is giving the master control plane the access to create AWS resources on behalf of you. So in a typical Kubernetes cluster, there's a component called the cloud controller that will boot things like an ELB or an EBS volume so that your workloads can automatically use those. This service role is what gives that access, gives the AWS control plane access. After that, we then create the VPC hierarchy. And in the VPC hierarchy, we basically have a VPC, multiple subnets so that we can launch our worker nodes on highly availably. And then you'll also have an internet gateway so that you can actually traverse out to the network. After that, we can actually create the cluster. So this is the actual EKS cluster. So behind the scenes, we're creating a highly available etcd cluster and a highly available master control plane for you. Once you have that, you then provision the worker nodes. And so these, similar to the way that ECS works, you'll deploy EC2 instance directly into your account. With those EC2 instances, they'll have a configuration file that allows them to communicate directly with the EKS control plane, but not immediately. you first actually have to go and apply the AWS auth config map. Once you do this, it will actually tell EKS how to connect into, it'll tell the master control plane how to actually allow your instances to connect in. Once that's done, you have full access to launch all workloads you want. Your nodes will be alive, and we'll actually show this in a little bit. With Terraform, you can just create the cluster using Terraform apply, plan, and output. And what will happen is your whole cluster will come up. So now I'm going to jump into a quick demo of how this all works. Let's see if I can move this over. If that is too small for anybody, please just let me know in the chat and I will make that a little bit bigger. So here, we're going to run Terraform plan. And before I actually got started, just for the sake of time, I brought up a cluster. It'll take about 10 minutes, and I don't want to take up all the time just bringing up a cluster. So what we have here is we have a cluster that was brought up using Terraform. The state is stored in a Terraform state file locally. And you can see things like the IAM role. We have the demo cluster created. And if we go through this, we can just check a couple things. So Terraform version. And we can see we have a couple providers installed locally. As Adam was talking about, that rich environment of having providers that we can actually contribute back and make the Terraform ecosystem really vibrant. Then what we're going to do is we can go do a Terraform apply again on this, which shouldn't do any updates, but we should do it just in case. And that's going to go through and actually refresh the state. Since we previously created this cluster, I have everything up and running, but I didn't connect the actual nodes in here. I'm going to clear that. What we're going to do this is we're actually going to use Terraform output, and we're going to pass in kube config, and we're going to pipe this to a file. Now you'll notice that I already set up my environment variable to auto-populate. As you can see across the top, my shell will automatically export or display the current context in these two brackets right here. So when we do this, the next output, output. Now you'll notice that this this set of brackets actually came out and have AWS in them. If we want to check this out, we can do kubectl config view. And you'll see the cluster that I'm actually connecting into. So now that we have this cluster up and running and we're able to connect into it all using Terraform, I'm going to kind of give you the lay of the land for this directory structure and the manifest I have. So in here, we basically have an outputs.tf. So this is what we just used to actually create that kube config file. And these are all using Terraform variables that are all passed through from the state file. So we have that. And then you'll also notice up at the top, we have this config map that defines the demo node ARN. And so this is where we actually went and deployed the nodes, and we got an ARN back for the instances. And in this, before we can actually use our cluster, you'll notice that I can do kubectl get pods, and nothing will be there. Then I can try doing nodes, and you'll see none are there. Although I did this Terraform apply, which means that it should have brought those up. So let's get those connected. First, we're going to run Terraform output again. And this time we're going to do config map AWS auth. And just to see what this actually looks like, that's going to be the ARN for our instances. We'll clear that one more time. And we're going to now do this and pipe it into AWS auth.yaml. Now, what we can do is use kubectl to apply this Now in a second, that'll come alive and we can actually do kubectl get nodes, and you'll see that some are not ready. So let's put a watch on that and let's sit there and wait for that to actually come up. So what's happening behind the scenes is we deployed a config map with the instance ARN of the cluster of the nodes. And what we're doing is we're telling the EKS control plane that this role should be allowed to connect in and act as worker nodes in the cluster. And so you'll notice my output just continuously appends to the end. So I'm going to close this out. It looks like we have both ready. And if I go to get nodes again, you'll see both of my my worker nodes are ready and I can schedule tasks on this. So let's go and see, let's talk about what we actually just did here. So with this whole directory, which again, I can show you a little bit of the insides of it. We have the EKS cluster, TF. And what we did here is we actually went and created an EKS cluster. We specified all of the subnets, all of the security groups that we need, and what it depends on to actually make it happen. We have our security groups. We have our our IAM role policies. And then we have our policy for the service role that needs to get created. We have our EKS worker nodes. So this is creating that auto scaling group with our launch configuration and all of the user data to actually connect into the EKS cluster. And then we have our VPC, which was created first, which looks like this. So it creates a couple subnets and an internet gateway and the VPC. So now that we have this all up and running, we basically went and created the VPC infrastructure. We created the highly available EKS control plane. We provisioned the worker nodes. We used Terraform to generate the kube config. And then we used Terraform to generate the AWS auth config map. And we finally applied that using kubectl. If we wanted to take this a little bit farther, because of that rich nature of providers within Terraform, we can actually go, and I have another directory that's specific to Kubernetes. So if I go into this directory, you'll see that I have a couple files in here. I have my main.tf, and in here, we're actually creating Kubernetes resources described using Terraform config files. So I'm saying I want to create a Kubernetes namespace. I want to create a Kubernetes pod. I want to then create a Kubernetes service. And all of these are using variables in Terraform just like a standard installation. So if we go and look at the variables file of this, you can see what I said. So in here we have variable of the namespace name being the demo service. We have the pod name being demo service. And then we have the Nginx pod image, which is specified to the latest version of Nginx. And because this is all Terraform, we have the ability to basically just go Terraform apply. But first, let's actually plan and see what happens. So you'll notice that it was able to look through all of that and realize what it's supposed to create. Let's just do a quick review of that. So it creates a couple annotations, some labels. Again, in the pod, does the same thing, sets the image policy, pull policy. So let's try and do Terraform apply on this. So this is going to review the plan again, ask us if we want to add 3 things. We're going to type yes. Looks like the namespace was created. Pod is still being created, so it's going to sit there and wait for that to actually get brought up. Then the Nginx service is getting created. And so now we can do kubectl get namespaces. And you'll see that I now have a demo service namespace in there. And we could say get pods -n demo service. And you'll see that we have a pod running. Let's just do a -o YAML, so we can actually take a look at what that created. So in here, we have the status objects, but we also have the pod that's in that demo service name in the demo service namespace. Then we have the actual containers, which is the Nginx latest image, like we specified before. And the name of that is again going to be demo service. And then let's do one last check. We're going to do kubectl get svc, or let's actually write it out, service -n demo service. So now we have a demo service in there. And let's do o wide, so we can actually see that because we specified the type load balancer and Terraform behind the scenes created the service role with the proper permissions, it was able to go and provision an ELB in my account that we could then use to connect directly into this application. It's pretty fantastic. So just to recap, we've created an EKS cluster that we can see here after we go through plan. And everything is still up to date in state. No changes were actually made. And then we were able to, all using Terraform, and then we were able to move over into another directory and go and actually apply our manifest for our Kubernetes applications. Now I'm going to pass it off.
All right, hello everyone. I am Ben Somogyi. I'm a principal system architect at Pearson. You can get a hold of me on Twitter or LinkedIn. And today I'm going to talk to you a little bit about how we're putting to use some of these technologies within my team at Pearson to basically achieve our mission. So what some of you may or may not know, well, as today you probably know Pearson as an education company, but what you may or may not know is that Pearson began in the early 1800s as a construction company, and then in the early 1900s transitioned into a publishing company. And today we're in the midst of a digital transformation. So we're no strangers to change, but we're transforming basically because the learning landscape is changing and growing like never before. Enrollment at schools is way up. By 2025, it's estimated there's going to be 262 million students enrolled in higher education, and there's a huge market for lifelong learning, corporate training, and professional education. And this revolution is also reshaping how we learn, with parents, 87% of them viewing classroom technology as important to their child's success, with 5.5 million US students now taking at least one distance education course, and our educators relying on internet content in their classrooms. So here at Pearson we have a vision, and that's, you know, to empower human progress through learning. And my team specifically is the cloud platforms team at Pearson, and our mission is really to provide capabilities to accelerate the delivery of applications that really contributes to that overall Pearson vision. So digging in a little bit, our mission within my team is really accelerating application development within Pearson, getting new learning apps out to end users as quickly as possible. But we also want to make sure that those learners are secured and that we have a platform for those applications to run on that's highly available, fails, scales, and performs with the rising demand. And then we also focus on making sure we have a solid operating model for our platform to provide that support to those applications and make sure we're optimizing costs as we build out our infrastructure. So this is a pretty high-level concept diagram of our paths that we've built, and really the red boxes are what I wanted to highlight, and really that's, you know, we provide we're a multi-tenant platform, so a lot of Pearson development teams are hosting applications on our paths, and we provide a lot of backing services to them. So one piece is secrets management. We use HashiCorp's open source vault project to really provide a service to our development teams to manage and consume secrets for their applications. And then we also practice infrastructure as code. We automate everything for our platform. From ground zero up to full paths in the cloud is all automated through Terraform. So I'm not going to really dive deep into our paths architecture because we could spend a long time talking through it. But I really wanted to highlight that some of these technologies are enabling development at Pearson. So next couple slides are really how we're using those technologies, and one being Vault. It's supporting our mission to secure the learner experience. It provides seamless integration into Kubernetes to provide that secrets management capability for our customers, which are Pearson development teams. But we're also using it for our TLS termination. So we've built a couple controllers that are out there open sourced and linked below that you can definitely contribute to or go and use as you will. But we have two controllers, an Nginx and Vault controller. And basically, as new Kubernetes services and ingresses come online for deployed applications, our Nginx controller consumes certificates that we store in our Vault cluster, and those get added automatically into our Nginx config to allow ingress into those services. So it's a kind of a really nice integration, and we love that it's an open source project that we can put to use. The next area is really Terraform and EKS provider support. We provision the breadth of our public cloud infrastructure via Terraform within our team, and we got a great opportunity to work with HashiCorp and Amazon as they were progressing to make EKS generally available. To date, for the past several years, we've been managing our production Kubernetes clusters with automation, but they're very difficult to do control plane upgrades to without causing some kind of downtime or having very complex orchestration to get those clusters upgraded. So, being able to use a managed service like EKS really puts us in the position where we can allow the Kubernetes upgrades to be managed by Amazon and focus more on providing those backing capabilities to our Pearson development teams. So it's been a great experience, and it's really nice that HashiCorp and Amazon were able to work together to provide the provider support right up front with EKS going GA. So that's kind of how we're using the technologies. Feel free to reach out to me. I'm definitely open to answering questions offline if you want to understand a little bit more about our Pearson use case.
Thank you, Adam, Chris, and Ben. At this time, we're going to open it up for questions. If you have any questions, please enter them into the chat box. So while those are coming in, it looks like, Ben, one of the questions that we had come in for you were, what were some of the biggest difficulties for adopting EKS?
One of the biggest hurdles we have to, get through with using EKS was to basically, when we had full control of the control plane, we were putting add-ons in place via manifest files in our Kubernetes clusters. So, we had to do a decent amount of refactoring to make sure that we have the appropriate orchestration for add-ons to get deployed into the clusters. So that, I think that's the biggest hurdle with the amount of add-ons that we have and how we had to now treat Kubernetes as a black box.
Thank you. Chris, we had a question come in. Do you find any advantages between managing Kubernetes with Terraform instead of using kubectl?
So I think the ease of use of Terraform and being able to actually just do Terraform apply on a full directory is fantastic. Being able to bring up a cluster without really having to do much, basically set it, walk away, 10 minutes later, you have a cluster, you output the kube config. I think it's an amazing way to actually work with EKS, and really trims down the initial getting started.
Thank you, Chris. Adam, you may be able to address this one. What would you say some of the advantages of using like Vault for secrets management versus like the Kubernetes secret service? What's the advantage of incorporating Vault into that? And then Ben, as a follow-up question afterwards, what were some of your thought processes or decision-making in using Vault instead of a native service?
Okay, sure. So I'd say one of the main things is that you're centralizing all of your secrets into one place where you can then use a multitude of different identities for actually authenticating. We've got direct integration with Kubernetes as well. And then just a rich set of auditing that comes with it too. So I'd say those are some good reasons to use Vault.
And from our point of view, it's nice that we were able to, build a containerized cluster that lives in our Kubernetes ecosystem to handle that secrets management. And then, we kind of used it for the ability to, interface with its API to provide that nice integration that we have with Nginx.
Excellent, thank you. Let's see what we have in here. Chris, we had a couple questions coming in about the differences between ECS and EKS, but in particularly one about, are you able to run them simultaneously?
Absolutely. So earlier this year, I think it was in the last month or so, we released a new feature for ECS called ECS Service Discovery. And behind the scenes, that's using Route 53 and a couple new APIs that can handle the churn of services and the churn of IP addresses a little bit easier. And so what we have now is the ability to boot up two clusters, an ECS cluster and an EKS cluster, or actually a standard Kubernetes cluster as well, and use that intermediary via external DNS on Kubernetes, which is a project that allows you to control your Route 53 chain set or namespaces using Kubernetes manifests and labels. And then in ECS, you can directly hook into that service discovery and have the ability to traverse from one cluster to the other.
And just as a follow-on to that, what Kubernetes services are supported, or what Kubernetes add-ons are supported by EKS right now?
Yeah, so anything that you can actually deploy on the worker nodes will work. There are, for right now, for example, you can deploy the dashboard onto it. You'll need to make a couple changes. We have those documented in our documentation. You'll be able to deploy in the long term things like HPA or horizontal pod autoscaler. Right now, we have a couple components that need to be deployed first. And then pretty much any Kubernetes add-on that you have the ability of running directly on the worker nodes is fine to run in EKS.
Thank you. Let's see here. We had a number of questions coming in. So Chris, sorry to put you on the spot again, but so we had a question about the different providers that you were using. Could you talk a little bit about how you were using the AWS provider for EKS and the Kubernetes provider in your demo? Just kind of talk a little bit about the differences between what you did there.
Yeah. So the default, as Adam kind of talked about in his early slides, there's like a rich ecosystem around Terraform, and there's hundreds of providers that we can actually integrate with. With those, what we did is we set up the AWS provider to actually work directly with the AWS APIs to deploy all of the AWS resources. So that was deploying the VPC, the EKS cluster, the subnets, the IAM roles, everything that you need to actually bring up an EKS cluster. And then I used another provider that was called an external provider, because I had to actually I had to use a shell script to actually do the authentication into the Kubernetes cluster. And then I used the Kubernetes provider to deploy the actual Kubernetes manifest. So rather than doing all of the configuration files through YAML manifest files, I was able to do them and describe them in Terraform and be able to just do Terraform apply directly on those to make those resources.
Okay. One more question on EKS. Chris, does EKS have a dashboard like Kubernetes?
It doesn't. So it supports the standard Kubernetes dashboard. So we didn't reinvent the wheel and build a new dashboard. Because customers know and love and have been using the Kubernetes dashboard, we just made sure that it was fully in support of that.
Thank you. Ben, we did have a question come in just about your platform. Could you tell us a little bit about maybe what are the next big steps or next big things that you're looking to accomplish with your platform?
I mean, the biggest things we're focusing on at this point is really enabling backend services. So we have a lot of development teams that have a need for databases and moving to develop out our DBaaS capability within our platform. As well as a lot of other backend services that we have requests coming in for. So really, it's just focus on internal development teams within an organization. As the architecture kind of matures with our paths. So.
And last, we've had a number of questions come in. Chris, are you going to be making some of the demo available after this webinar?
Yeah, it'll take me a couple days, but I should have it up probably around the same time that we get the webinar video up. And we can probably put that in the notes for the video.
Excellent, thank you. We'll make sure that we share that. Okay, at this time, I'm going to, we have a number more questions coming in, so give me one moment. Okay, let's see. Adam, can you talk a little bit about just kind of our plans for Terraform providers and a little bit about how we work through adding those? So just making sure that to kind of give an idea of the back end about where the community comes in terms of creating providers.
Sure. So I'd say it's a mixture of a couple of different things. One is the community itself recognizes that there's a gap and will work quickly to close that, sometimes within a day. Then and that would be potentially a resource on a provider. Then along with that, the major cloud providers like AWS will also work directly with us on creating different resources, and for say EKS, recognizing that there's a big demand there, and we've seen this actually across all the different cloud providers. And then along with that, we have documentation out there in terms of being able to build your own because of the way that it's built from an extensible perspective. So hopefully that answers it.
Yeah, thank you. We did have a couple questions come in, Chris. Can you talk a little bit about, can you have a different, can each node have a different instance type when you're using EKS and Terraform together?
So not each node. So under the hood, what's happening within EKS and a typical Kubernetes distribution on AWS is you use auto scaling groups to actually wrap what we're calling node groups, or if you're familiar with like COPS, for example, that'll be considered an instance group. And what happens is we wrap that in an auto scaling group, and everything is managed by a launch configuration. So if you wanted to actually run multiple instance types, you'd create multiple auto scaling groups. And this is a good best practice for a couple reasons. One, because you can actually then do auto scaling of that specific workload type and be able to schedule directly on those. For example, if you wanted to run a GPU type workload, you could tag those instances through the auto scaling group and be able to schedule directly on those and auto scale only those instances when you need to boot up versus maybe the lower memory and CPU instances that are just running your web applications.
Thank you. And one more question on, was it EKS came up. Does it use etcd version 3 and encryption at rest, or can you talk a little bit about how you're protecting the data for the nodes that are being managed by EKS?
Yeah, so behind the scenes, everything is encrypted. It is using etcd v3, and the customers don't have any access to that. So from the control plane side of things, we completely augment all of that away. So you don't even need to think about etcd. We handle all the backups for you. And we'll handle the dot releases or the patch updates as going forward.
Excellent, thank you. Okay. So at this time, we're going to close the Q&A. I hope everybody enjoyed today's webinar and has a better understanding of how you can use Terraform to manage Kubernetes and how EKS as a service works. I really want to give a big thank you to Adam, Chris, and Ben for their time today. And as I mentioned at the beginning, this webinar was recorded, and we will be making the recordings available on our website after processing. I will also be sending out an email to everyone who registered with the recording link. You can keep your eyes on Twitter, where the recording link will be made available as well. And I also just want to say, I know we did have a large number of questions come in. If you check on HashiCorp.com/resources in our library, we do have a number of other items available talking about managing Kubernetes with HashiCorp tools. So again, I want to thank our speakers for the time today, and I hope everybody has a great day.